falls into OLAP. So these are some of the differences. The OLTP is day-to-day operations, and OLAP is used for the decision support. Suppose we have a product and we need to decide like how is the sales in particular area for last 5 years. So in that case, we can query the OLAP and we can get the output. With that, we can decide what has to be done to improve the business. So coming to the database design, mostly OLTP are application oriented. Like it can't give you any suggestions, or means you can't get any valuable feedback from the OLTP system because it's just a transaction. So OLAP, we can make decisions from the query outputs. And OLTP contains the data which are up to date. Like OLTPs are auto committed. Like whenever you do a transaction and do a commit, it's automatically updated in the OLTP systems. But OLAP, it's like you extract the data from heterogeneous systems, and then you do the ETL, and then you load the data into the system. So it's usually like D-2 or D-1 data. So coming to the usage, this is a repetitive, like the same operations will be repeated. And OLAP, it's ad hoc, like you can give whatever queries you have, like you can write SQL with whatever request you had in mind, and it will provide you the output of the data it has. And coming to the access, it's a normal read and write, but in OLAP we do lot of scans, joins with multiple tables to get the required result. And usually these OLTP queries are short and simple within a transaction, but OLAP queries are complex and they run for hours, even days to get the data depending on the complexity of the query. So OLTP is designed to maintain less number of data. If a data grows high, right, OLTP system won't be able to run your queries. But OLAP is mainly designed to run the queries on historical data. So the metric is the main metric for OLTP is transaction throughput. Like your transaction should get committed or rolled back. That is the main aim. But here in OLAP, it's like query throughput and the response. Like query throughput and response in the sense like you run a query containing historical table. So how long it takes to retrieve the data. So this is some of the example difference. And coming to parallel computing.
Ashwin.
Yeah.
Ashwin, can you hear me?
Yeah, Manju.
Okay. Okay. Okay, fine. No, because I came on the headphones. Okay, that's why. Okay, we continue. Yeah.
Okay. So coming to parallel computing, we have two main components of parallel computing. First one is symmetric multiprocessing and massively parallel processing. So when we talk about this symmetric multiprocessing, so these databases, what will do, it will share everything like operating system, memory, and even storage. So they will share everything, and then it will produce the output. But when we come to massively parallel processing, so it has a share nothing architecture. Like it has nodes, and each node has their own processing unit, like CPU, RAM, and also the drives where the data disks where the data are stored, it's different. Like the MPP system doesn't share anything, either the storage or the computing. Okay, so our Teradata falls into MPP, massively parallel processing. So one thing is, even we can tell like Teradata is SMP in case if we have only a single node with single P and amps, but that is not gonna use, we not gonna use anywhere because we want Teradata to be used for large set of data. So usually it's a MPP. So this is what I was. Yeah.
Okay. Can you just brief about the normal system? They can, in the sense, like whatever the laptop we are using, and how exactly the Teradata server
Right.
is. Is
Yes, I will explain it here. So if you see this diagram, right?
okay.
Yeah. So the first one is a symmetric multiprocessing, which means like if you can see, it's a shared memory and the drive hard disk you see that is written as IO, right? It is a both are one, right? One memory and one drive, and which is connected to a bus, and then which is connected to the CPU. So even if we have number of CPUs, right, like a quad core or hexa core CPUs, but when it
Okay.
comes to the memory and the disk, it is again dependent on whatever we are having, right?
Okay. Okay.
So
Okay. Here,
yeah,
can you just correlate these terms to RAM, hard disk, and these things?
correct. Okay.
Shared memory is RAM, right? You're saying.
RAM, yes, the shared memory is the RAM, and this
Uh-huh.
IO which is written, right? So that is the disk. Your hard
Okay.
drive.
Okay. Fine.
Your hard drive.
Hard.
So
Okay. Okay.
even if you okay, like if you take your system as an example, you know VMware, right?
Yeah. Yeah. Yeah.
Yeah.
Correct.
So even if you run multiple VMs in your system, again, it is dependent on your memory and the hard drive, right? So whatever you have
Yes.
is dependent on that.
Correct. Correct. Yes. Yes. Yeah.
So this
It
is
will take the memory from the
physical,
RAM, and yeah,
correct,
and we can create
right,
uh, virtualized environment.
correct. So this is the example for symmetric multiprocessing. And when we move to a massively parallel processing, right, we have everything,
Okay.
in a separate manner. Like nothing will be shared within the nodes. So if you see here, we have three nodes, and then we have separate uh, drives here connected to the nodes, right? So this is the logical representation. Even in physical, right? We have like racks of nodes connected together. So in every node, we have a separate processing unit, that is your CPU, memory, and it will be connected to the drives separately. So even the node one here, it can act individually and produce the results without interfering with node 2 and node 3. So this is the advantage of MPP and shared nothing architecture.
Uh, okay. Here. Okay. 1 minute. What you're saying? Like here, each node we can call it as one SMP, right?
Yeah, that's right. Yeah.
Okay. Okay. Uh-huh.
Yeah.
And this is connected to internet. What are this A to F is something you're saying?
This is nothing, just a data representation like A, B, C, just like that.
Okay. Okay. Fine. Okay. Okay. Yeah. And can you please explain? Okay, maybe you are going for the next slide on the AMPs and these things.
Yeah, yeah, sure. I will explain those too.
Yeah, because I need to understand. I know AMPs and PEs are virtual processors.
Mhm.
Okay, and Binet is a kind of a connecting wire, and Binet software is also there.
Correct.
Okay,
Yeah.
so I just need to understand how Teradata
Mhm.
do this parallel processing
Mhm.
using the resources and getting all the resources and working parallelly
Right.
by unleashing the uh, memory and this hard drive or virtual disk. So I need to understand that concept
Sure, sure. Yeah,
clearly.
yeah. I will let you know that also. Yeah. So
Okay.
this part is clear, right? We can move to next one.
Yeah, yeah, sure, sure.
Okay. So this is just an example of what is Teradata. So might be as you're already working on it, you should be knowing this, right? So it's a DBMS system and it's designed to run the world's largest commercial databases. And it's compatible with the ANSI industry standards, and acts like a single server, even though we have multiple nodes. And like you can run it on a single or multiple, that is you can run it as SMP or MPP. That's what it means. And it's an open system which can be run on Linux, Windows, and currently they are into cloud with the name called Vantage, Teradata Vantage. So the main objective
Okay.
is it's built on parallelism. So to get the
Have you got a exposure on Teradata Vantage?
no, Manjunath, not actually.
Okay,
Yeah. So
okay, okay.
currently the project which I'm is having a data center. So they are not moved into Vantage, but they are moving into Snowflake actually.
Okay, 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 fine. Thanks.
And this is the history of how it got created. So the first database was founded in 1979, and then they developed the Binet in 1982, and they got it patented. And the first database, DBC, it came in 1984, and we still use this DBC in system, right? So it's the main parent database. So we'll let you know that when we go through the databases and things. And Wells Fargo is the first bank which purchased Teradata as a database product. And 1992, they merged with the NCR, and in 1997, it became the industry leader in data warehousing. And for decades, it still remains as the leader, but not sure about the future since a lot of new data warehouses are came in. But I think in 2020 also they got the leadership in Gartner report in data warehousing.
Okay, okay. Um, okay, I think you have worked on a Snowflake site, correct?
Yeah.
Do you think Snowflake or Azure Synapse or whatever the environment that is created as an alternative for Teradata,
Uh,
is that will give that much performance compared to Teradata?
no, actually, I have seen customers where they migrated from Teradata and then they means to cloud, and then they came back to Teradata saying that they're not getting the same no result like query processing and those things. But what I feel is Snowflake is little bit comparative with Teradata, but I don't think other warehouses like Azure Synapse or
Okay,
uh,
have you worked on no, okay, have you worked on or have you got exposure on AWS side of Redshift?
uh, no, yeah, I didn't get a chance to work on AWS because
Okay, okay, because some people configure Snowflake on Snowflake on Redshift also, or I think Amazon. I don't know. I'm not sure. Okay. Yeah,
Okay.
Snowflake is there on AWS also, correct?
Right. It's in both Azure, AWS, and I think it's coming up in Google
Okay.
Cloud too.
Okay. Okay.
Yeah. So the Snowflake is again almost, if you see the architecture, right, it will be almost similar to that of Teradata, but only thing is they have few different features like warehousing, those kind of stuffs. But most of the things I feel is similar.
Okay. Okay. And during this migration, after completing into from Teradata to Snowflake and all,
Hmm.
customers still using the Teradata, they're completely migrated to Snowflake, or how exactly they are going part some 75% on Snowflake, 25% on Teradata, create some critical applications like that, or how exactly?
Okay, actually, what the problem here with migration is, right? So they need to first create the new projects in the Snowflake, and then they have to start migrating the old ones, historical data, right? So what is happening? I have seen with one or two customers which I have worked, like they even plan to migrate, but they stay with Teradata for more than 2 to 3 years. They are still not able to decide whether to go out or not. So mainly these
Okay.
upcoming projects, they are moving into the cloud, and historical data is still staying with Teradata only.
Oh, okay. Okay.
So moving on to the architecture. So this is the main components of Teradata, like parsing engine, we call it as PE, and Binet as you told. So AMPs, or AMP is access model processor, and the disk, the storage. So if you see here, P is like brain of the system. So uh, it is like the brain of the system which passes the commands to the AMPs to retrieve the data, to write the data into the disk through the Binet. So Binet here is a communication channel through which PE and the AMPs communicate with each other. Right. As you know, like we have both software Binet and also hardware Binet. So usually in production system, right, it will be a hardware Binet. So need to accommodate all the traffics passing through the P's and AMPs. So it will have a huge network, like a gigabyte of network interfaces, and it will be like active and standby, like both the binaries. So in case of one goes down, the other will come up and it will pass the values. So we'll see about all these components one by one in detail. So
Okay.
yeah, so coming to the parser engine, as I told, it's a main component of the database. So the responsibilities of the parser engine, right? So it will it will no, you will pass the queries to a parser engine only first. Like suppose you write a select star from some table, that will directly go into a parser engine, and then there are some particular uh, steps which is done in parser engine. We'll see about those steps. Okay, so the components, right? First, let's see about the components. So these are different components the P has. So the first one is parser. So what will happen? It will dissolve the SQL statements into RDBMS processing steps. So suppose you run a select star, that is a SQL statement, right? So what will get the parser will do? It will break up the SQL statement, and then it will write it into a format which the system can understand. So that is the work of a parser. And the next component is optimizer. So the optimizer will decide like what is the best way to collect the data which the user requested, right? So it will create a plan which will be uh, you know very less in cost, we can say. And the next step is next component is step generator. So this step generator, it will generate steps like um, after the optimizer decides like the which way we can retrieve the data. The step generator, what it will do, it will generate steps. If you ever have a, chance to look at the explain plan, right? Maybe if you have
Yeah,
seen,
yeah, correct, correct.
right?
Yeah, I have seen.
Right. So there will be steps like we do full table scan on this, and we store it in a spool. So
Yeah.
all these steps are generated here by the step generator, and then those steps are passed to dispatcher. So the dispatcher will dispatch the generated step through AMPs, to AMPs through the binary. So the AMPs are
Okay.
like, yeah, the AMPs are again the slaves which work and retrieve the data. That we'll see like how it works when we move on to the AMPs. So, and the other component is session controller. Sorry. So this manages the session controlling activity like log on authentication and log off kind of thing. So each P can hold about 120 uh, sessions at a time. Right?
Okay.
So going back, this is the pictorial representation, like the parser engine which have a session control, parser, optimizer, and dispatcher. And then when the SQL request comes in, it passes through all these components, and the final plan is passed through the AMPs, through the binary. The AMPs retrieves the data and passes it back to the parser engine through binary, and then the answer set response is passed to the user.
Okay. And say for example, if you take SMP, how many PEs might be configured in the case, because if you want to understand how much load that server can withstand, okay, based on the number of individual sessions people can connect, as you said, one PE may hold up to 120.
Sessions,
Okay.
yeah.
120 sessions, correct? Yeah, 120 sessions.
Right.
So if you want to do a capacity planning and project that to the team or application users,
Mhm.
how many users it can support, means in that case how can we do this planning, like are you guys are considering the PE or AMS, or how exactly, how many sessions it is going to
Uh,
consume?
yeah. So usually this capacity planning is done during the initial setup, right? Like how much users you're expecting, and how much growth you're expecting year on year, right? So these all are calculated during the initial setup of Teradata. So like these Teradata guys
Okay.
themselves, they will decide and they will recommend how many nodes you need to buy. So those kind of meetings will happen. So we as a DBA, we're not much worried about the you know uh, Ps and amps. Usually we have like hundreds of Ps and thousands of amps, right? So eventually
Okay.
it never caused a issue with the session control. Like it should be able to handle whatever the user we have.
Okay.
Yeah. And even Teradata will do auditing.
Can we see how many P's are there any through any query?
Yeah, we can examine how many PEs and even how many amps we have.
Oh, okay, fine. Yeah,
Maybe
thanks.
once we have the hands-on, right, like the live
Yeah,
session,
yeah, sure.
that time I
Okay,
give you the full.
okay, thanks.
Yeah. Okay, so the PE passing engine is okay, right?
Yeah, sure. Yeah,
Okay.
okay.
Okay. So and this is the thing, like your parser engine will know everything about your system, like how many number of nodes the system has, and how many amps it has, the type of CPUs, and then data demographics like number of rows, column information, skew values. We'll get to know each about skews and all in future sessions. So basically, your PE will have the knowledge of the entire system. So that's how it is able to create a best plan to fetch the data without any issues, right? And this access
Yeah,
path
yeah.
decisions is, yeah, this is what the P, it's like representation, like what access path, what type of join it has to do, and how the redistribution of tables has to be done, and whether the duplication has to be done. So these kind of things the P is taken. And coming to the AMS, as we said earlier, so AMS are like the worker task, like slaves to a system, to the PE actually. So whatever PE gives the command, the AMS will act upon it. So the basic responsibilities of these AMPs are storing and retrieving the rows from to and from the disk. Like it's the one AMP, the rows will go through the AMPs and it will store and retrieve from the disk. And it will also have this blocking mechanism, sorting of rows and aggregating columns, processing the join which we give in the condition, and output conversion, and data retrieval mainly. Uh,
Okay, that means for okay, no, okay. That means for amps, PE will give the instruction, correct?
Correct. So in if we see here, so P has generated the plan, right, through this
Oh,
step generator. So this plan will be passed through each amps or whatever amps involved, and
okay,
through the binary. Yeah, and these amps will get the plan. So whether it is write operation or read operation, accordingly, it will do the work and pass the result back to the PE through the binary again.
okay.
Yeah. So this is a no flow of data, means how once you submit a query, how it goes through the PE AMS and then it retrieves the data, right? So if you see here, you're doing a select star from order table and you're doing a order by order number. So this user SQL is passed to PE, and all the syntax, semantic, and plan generation is done, and the P is planned, right? So if you see, this is example, like retrieve all orders from order table, sort them by order number in ascending order or descending, and pass the result back to me over the binary. So this is like the P is plan, right? So it is passed through the AMP and it will be delivered to the AMPs. So these AMPs, right? So it will right, it will retrieve the data from this order table, whatever. AMS it is amming, and then it will pass back to the PEs.